You know, coordinate geometry. Coordinate geometry is done. Don't be thinking, but 9 point circle remains the problem solving remains. We'll do it later. First, what is necessary for us to do is our not this coordinate geometry. We won't do this coordinate geometry. We shall do now about equations. Equations. Now you might be thinking, what's there about equations? It's all about 2x plus 3 equal to 0, then x equal to minus 3 by 2. Take now. You might be thinking only about that only. That's the only case here. But no, you know equations are divided into types. Now on which basis we are dividing it? We'll find it out with the help of our what? With the help of our definition. The definition is a mathematical statement, okay? A mathematical statement whose form is a x to the power n plus a1 x to the power n minus 1 plus b a2 x to the power n minus 2 till it grows to the last a n x plus a naught. And mind the fact that a1 comma a2 comma a3 all these till a naught. Okay, perfect now. These all terms are constant and the x here is variable only. Variable. And no more two conditions are there. The third condition is that the a here, that's not a1. Oh no. A. Yeah, now it's perfect. So the third condition is that a, this first term a, cannot be equal to 0. Okay, now let's write 0. The a here cannot be equal to 0. Yellow, yeah. It cannot be equal to 0, never. Fourth condition is the n here, it is the highest power now. It's n minus 1, n minus 2, and these are all lesser powers. The highest power, now according to the highest power, there are n roots. Okay, that's all about. Means how many roots will be there? If there is 2, there will be 2 roots, 3 roots, 4 roots, and more than that. We'll do more this, we'll do the equations on quadratic, we'll do cubic, we'll show how to do cubic, quadratic, then 2 variable. I'll show you 5 methods to solve them. 5 methods. You might not you should know only 1, 2, 3 only, but there are total 5 methods and I will show you how. Okay now. 2 variables, 5 methods. Then I'll show you one of my derivation. It's not official, but it's my derivation of cubic equations. Okay, I'll show you. That's other case. Just you will then agree to me. Before this, we need the Vieta's theorem. Okay, now the Vieta's theorem we need, and your discriminant part is the polynomials only. Polynomials is just the same. We'll find about roots, or the named as zeros, or we name as the solutions, anything. Okay, we'll do these things only. We won't do linear as we have already done in the lower classes. Let's erase them all and just move on to see whether to identify what is an equation or whether an thing is an equation or not. You are given ax square plus bx plus c equal to 0. Now you have to state whether it is true or false. Think for 5 seconds. Think for 5 seconds and write the answer in the comments. Is it true or false? Now see here. For an equation or statement, for any statement to be true or false, we have to see whether it satisfies the conditions or not. Okay now? We have to see whether it satisfies our conditions or not. Conditions are, first condition, it should be in the form axn plus bxn plus 1 plus c, like that, and it's in that form only. Take now. In place of a2 here there is b only, and in place of a naught there is c. A naught is constant na, and c here is also constant. It says that it should have n roots, means here n equals to 2, therefore it has 2 roots. Yeah, it has 2 roots, minus b plus root over b square minus 4ac whole divided by 2a, and minus b minus root over b square minus 4ac whole divided by 2a. Yeah, these roots are there. You might be thinking, how did I get that? We'll discuss it later on. We'll do this proof only today. In today's lecture only, we'll do the proof. Now whether it is true or false. Let's see our next mathematical statement. Yeah, it's a statement. Here x is a variable. Yeah, true. These are constants. A, B, C are constants. Yeah, there should be real numbers only, na. They should be real numbers only. Yeah, they are real numbers, suppose. Suppose they are real numbers. Now only one condition remains. The condition is a not equal to 0. This condition remains. Now is it satisfied here? Maybe yes, maybe not. Nah, because here it is not stated only that a not equal to 0. Correct na? Therefore, this statement is not true, it's false. Now hopping on to the next, given 3x square plus 5x plus 6 equal to 0. State whether it is true or false. True or false. It is true or false. Wait. Oh no, leave it. Sorry. Let there be another one. Let there be the equation x square minus 5x plus 6. Is it true or false? Is this equation true or is this equation false? Now we know it has 2 roots. These roots are 3 and 2. This satisfies our first condition that it should have n roots, and there are n only, n equals to 2 here, and there are 2 roots. X is variable, yeah. All these terms are constant. 1, 5, minus 5, 6. Yeah, these are constant only. And roots a not equal to 0. Is it satisfied here? Yeah, of course. 1 is not equal to 0. Here it is 1 only. 1 only, na? 1 into x square. Therefore, this statement is true. We have identified whether an equation is true, or better to say it's a statement. whether a statement is true or false. Done. Let's now hop on to what we know as quadratic. Yeah, quadratic. Quadratic. For quadratic, we need the same statement only. Let's see how. What we do is just copy the statement, whole statement, duplicate, bring it below. Yeah, now. Now, what should the differences? Statement where here x will be, it is only 2. This term won't be. Let me change the whole one. So same now, but it should be ax square plus bx plus c. Let's see. A1, A2, A3 are written, but it should be A, B and C. For this part, A, B and C are constant. A not equal to 0, yeah, it should be, there should be always. There are n roots, no. There are 2 roots. And A not equal to 0 is uniform for every mathematical statement or equation, you can say. What is this? This is our statement for quadratic equation. What is basic form? Its basic form is ax square plus bx plus c equals 0. Yes, na? Now, mathematical statement, yes. Now, let's write an example. Let's write the previous one. X squared plus minus 5x plus c equal to 0. It should be x. If we do middle term factorization, it smells like middle term factorization, na? And it will be. Then it becomes x minus 3 into x minus 2 equals 0. Then x equals 3 comma 2. X equals 3 comma 2. And these are its solutions. How did it come? See here. We have done wavy curve. Now for wavy curve, we draw a line. What are the critical points here? 3 and 2. Oh. 2 and 3 equal, therefore they will be solid, and no greater than, lesser than, therefore the 2 and 3 will be answer. In the other way, we first divide both sides by x minus 3, then it becomes x equals to 2. Then we divide both sides by x minus 2, then it becomes x equal to 3. Simple, quick, easy. Now, an equation is given. X square plus x minus 1. Does it simplifies to any middle term factorization? You want me see? We'll do in the way that x square plus 2x minus 1. In that side, will minus x plus 2. It may work now. Let me see it. Plus 1. Okay, I've done wrong. It should be minus 1. There should be plus 1. Plus 1. Then there would be minus 2. Okay, this should be done now. X plus 2. X plus 1 whole square. Yeah, that's the problem. It's x plus 1 whole square minus x plus 2. And it does not make any sense. How can we do it? We cannot do any middle term here. Just what we need to do is to derive a formula for Quadratic equations. Let's try to derive one. The order of derivation statement says ax square plus bx plus c equals 0, where a is not equal to 0. If you just see, divide both sides by a, then becomes x square plus b by ax plus c equal to 0. Since c by a, okay. Since a is not equal to 0, we can divide. Now, we will try to make it a whole square so that it becomes, we get some root there, that way. A square plus b by ax, we have to convert it into 2 into something. 2 into a is x into b by a. This is our c part now. Now it goes to 2x b by a, which is not equal to b by a. What we have to do is divide both. Divide this by 2. Then it becomes b by 2a. And 2 cancels. B by a into x, this term only. Plus this term whole square, b by 2a whole square. Plus c by a equals 0. We'll take whole square of this. Now wait. We have done whole square now. Well, we have added this whole square to both sides. Becomes b by 2a the whole square. Now it becomes x plus b by 2a whole square equals to, it should be 4a square b square minus 4ac. Square root both sides. X plus b by 2a equals plus minus root of b square minus 4ac. Why plus minus? If there is x square equal to 4, then x equal to plus minus 2 na. Because plus 2 also satisfies the equation, minus 2 also satisfies the equation. Therefore, if we do a square root there, it gives us plus minus, and there will be plus minus here also. Plus minus. We'll take the b by 2 that side, then x equals to minus b plus minus root over of v square minus 4ac whole divided by, oh sorry, I did it wrong. 4a square will be 2a na. And that is what we get. This is what we know as, I derived this formula only. It was derived by me only. No, you always thought it was derived by me. No, it was derived by an Indian mathematician known as our beloved Sridhanacharya. And it is also known as Sridhanacharya's method, or better known as Hindu method. Hindu method. Okay now. So with the help of this, let's come to this equation. In this equation, how to solve it? What we have found is that x equals to minus b plus minus root over b square minus 4ac whole divided by 2a. Here a equals to 1, b equals to 1, c equal to minus 1. Correct now? Then x equals to minus 1 plus minus root over of 1 square minus 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 plus 4 whole divided by 2a1 is. Then it becomes plus minus root 5 minus 1 whole divided by 2. And these are the two solutions. One is plus root 5 minus 1, one is minus root 5 minus 1. Divided by 2 in both sides. So that's how we do all things. Today let's keep this very short, and we will end this lecture today here only. Thank you for watching. Goodbye. good day, good night, or anything.